let's take a look at another example where we're going to use substitution and expand a little bit off of some of the previous substitution ideas. So here we come across an example, the integral of x over the square root of 3 minus x dx, and it's definitely not one of our basic integrals. So then we start thinking about other ways that we could deal with this, and I see this 3 minus x here under the root, and that feels like a great candidate for a u. So let's give it a try and see if we can make the substitutions. So we define u to be 3 minus x, and then our derivative du dx is equal to -1. Separate the differential. I'm going to just do that with an eraser here. Multiply both sides by dx. And then we're saying, okay, I've got the dx here. I've got my u right here. Let's go ahead and just solve for dx. So dx is, when I divide both sides by -1, dx is negative du. So that's great. Let's get started. So we've got the square root of u, making the substitutions. Then this is going to be times, when I replace the dx, I'm replacing with -1 times du. And since it's multiplication, I'm going to put it in parentheses like so. Now here is the issue on this one. We still have an x left. So let's carry it over and see what that looks like. So this integral, when we simplify it, I'm going to pull the -1 to the front, becomes negative integral of x over the square root of u du, which we've made the substitutions, but we still have kind of a mess of an integral. It's not all in terms of u. And again, remember that that is the goal with substitution, because we can't integrate until we have it all in terms of u. So that's why we're making those substitutions. So we still have that little x left over. So what can we do with that? Well, a couple of things. One, we could go back, scrap the whole idea of letting u be 3 minus x and try a different u substitution. That's one thing we could do. Or before we do that, so before I scrap everything, let's take a look at how we've defined u right here and see, is there anything else we could do here? Is there a way I could algebraically manipulate this guy so that I could actually make a second substitution and get rid of that x? And I see right there that if u equals 3 minus x, well then x is equal to 3 minus u, adding the x and subtracting the u. So I can make that substitution, and that gets me somewhere. So now let's make another substitution. So make another substitution. So now our integral is going to become negative. The x we're going to replace now with 3 minus u over, I'm going to write that as u to the 1/2 du. And we look at that and think, okay, is there anything I could do? Can I integrate that? Not quite in that form, but because we have two terms in the numerator here and a single term now in the denominator, I can just use my rules of exponents. So this becomes 3u to the -1/2 minus, this is u to the first. So when I subtract exponents, this becomes u to the 1/2 du. And now I can integrate each of those terms just using the power rule. So now I can use the power rule here, and now we're cooking, because now we can integrate. So we can use that power rule, basic power rule. This becomes negative. We're actually going to do the integral. So it's negative. I'm going to put it in parentheses. 3, when I add 1 here, I get u to the 1/2, and I'm dividing by 1/2, minus, and I get u to the 3/2, and I'm dividing by 3/2. It's an indefinite integral, so I'm going to get plus c. I'm going to come down here just to finish this off. Let's actually scoot this up a bit. So we've got a negative. When we divide by, remember, you'll see me sometimes even skip this step of where I show that division by those fractions. When we divide by a fraction, it's the same as multiplying by the reciprocal. So this is negative, get back to my black pen. This is negative 3 times 2, so this becomes 6u to the 1/2 minus 2/3 u to the 3/2 plus c. I'm going to go ahead and distribute the negative and substitute my u back in. So let's get the u back there on the top of the screen there. U, remember, we defined as 3 minus x, so now I can plug that back in. So I get negative 6 times the quantity, 3 minus x to the 1/2, plus 2/3 times 3 minus x to the 3/2 plus c. And there is my answer, with a little bit extra work, right? We had to make another substitution in this particular case, But we were able to make that second substitution there so that we could replace the x with 3 minus u, and then that gave us the ability to integrate using our basic integration rules. So just another example where we're kind of taking what we know about substitution and just taking it a little bit further, continuing to manipulate and work with our integral so we can get it all in terms of u, purely in terms of u, so that we can integrate with respect to u.